Let's now start talking about nanocomposites, especially those coming out from graphene, from the carbon. Graphene is one atom only thick sheet of carbon with outstanding properties about mechanical resistance, electrical and thermal conductivity, and graphene is the precursor of all other graphitic structures. So by rolling into spheres, graphene yields fuller ends. There are beads, hollow and dense, with outstanding capability of electrical charge transportation. It's applied into the polymeric photovoltaic cells production. Then, when we stack several sheets of graphene, we obtain graphite, a well-known thermal and electrical conductive material. Lastly, by rolling, the graphene yields carbon nanotubes, which are cylindrical, tubular-shaped structures with a diameter of a few nanometers. The carbon nanotubes can be defined by the number of graphene sheets rolled together. So we have single-wall carbon nanotubes, double-wall carbon nanotubes, and multiple-wall carbon nanotubes. Anyway, at microscopy, carbon nanotubes appear as a tangle of fiber, as shown in the picture below. Why those carbon nanotubes are so interesting? Because depending upon atomic configuration and dimensions, they show outstanding properties, mechanical strength, thermal and electrical conductivity, and especially when added to plastics, they can turn the material from insulating to thermal and electrical conductors. In fact, this work starts from a research study performed at Proplast on the correlation between the electrical response and the anisotropic morphological behavior of plastics filled with carbon nanotubes during injection molding. By a digital twin built in Moldex3D, a link between the morphology and the injection molding variables was established based on the observation and measurements done on a simple rectangular specimen. Lastly, the digital twin method was applied to a plastic product, a capacitive touchscreen pen. Let's call it Proplast stylus pen. Now let's try to resume and summarize what are the main results about the analytical study. First of all, we started from standard polypropylene that has, of course, high resistivity and is an electrical insulator, but when it's added with carbon nanotubes in several percentages, but usually around 3%, we can get electrical conductive formulation by dropping down the resistivity of several orders of magnitude. Measurements